All right, so we're going to do problem number 29. I think the most difficult part is just kind of setting this problem up and understanding what's happening here. So the speeding motorist is the car on top there. It's going at 120 kilometers per hour. It's going to maintain that 120 kilometers per hour the entire time until it hits a certain point. At that certain point, the cop car is going to have caught up. The cop car is going to start at 0 kilometers per hour. It's going to speed up at 10 kilometers per hour per second, all the way until it reaches the car. And they're going to meet at the same point. Now, the cop car is actually moving at a different speed at that point, so we're not worried about how long does it take to go 120 kilometers per hour, because once it reaches 120 kilometers per hour, the car will be in front of it and it won't be able to catch up, right? We're worried about once the positioning is the same, but we're not worried about what that position is. We're worried about how long it takes, the time it takes for them to meet together at the same point. So this is a little bit more advanced, so if you're not quite catching it yet, we're going to be doing problems like this in the future as well, but this is really like AP kind of level problem here. So we're worried about when x for both of them is the same, right? When they both have the same x position, the same final position, what the time is during that, okay? We don't know the final speed of the cop car. We do know the final speed of the regular car is going to be 120. But because we're going to base this off of what the cop car is doing, so we know, let's just write down some variables that we know we'll call this this will be the black car, the cop car, let's make it blue. Okay, so for the regular car, the black car, x0 we'll call 0, x, we don't know it. The initial velocity is going to be 120 kilometers per hour. You know what? Sorry. I'm going to make all this red just to separate everything together. So this is actually going to be the red car. Okay, so x0 is 0. We don't know the final position. We know the initial velocity is going to be 120 kilometers per hour. We know the final velocity is 120 kilometers per hour. And we know the acceleration is 0. Okay, so from that one, we need to know the time too. The time is a question mark. So from this one, look, x and t are both question marks. If you look at all our equations, that means none of them are going to work, right? Because x and t are both question marks. If you look at the first one, we could figure out the time, but if you look and you plug in numbers, 120 minus 120 is 0, divided by something is still 0, so the time is 0. Because that really doesn't work in this problem. And we'll talk about that in a minute here. So what is going to help us here, let's write down the cop car's variables. So initial position is still 0 meters. We don't know x. We know its initial velocity is 0. Its final velocity, we don't know. We know its acceleration is 10 kilometers per hour per second, and we need to know the time as well. Okay, so same thing here, except now we have even more problems because we have the final velocity is still a question mark, okay? So let's talk about this, but first, they try to keep it into pretty easy numbers here, but let's just turn everything into meters per second just to make things easier for ourselves. So 120 kilometers per hour, we've already been doing this. It's 1,000 meters in 1 kilometer, so that those reduce. And in 1 hour, we want those to reduce. We have 3,600 seconds. Okay, so 120 kilometers per hour is 120 times 1,000 divided by 3,600, and I got 33.3. Okay, now the weird one. 10 kilometers. We really want the kilometers per hour to change, so let's leave that up top like that. we already know if we want to go from kilometers per hour to meters per second, we just multiply by 1,000, divide by 3,600. So if we multiply by 1,000 and divide by 3,600, we can change this into meters per second, okay? Because we know 1,000 meters and 3,600 seconds, and that will cancel out with the hours and kilometers, and so we'll get 10 times 1,000 divided by 3,600, and we get 2.78 meters per second squared. Okay, all right, so that will help us a little bit here. Okay, now we know the x's are going to be the same. So what we can do is we can set up an equation with x equals, and then those x's are going to be the same, so we'll set those equations equal to each other, and then we'll be able to solve for the unknown t. Yes. One annoyance here is that we're going to have to use the quadratic formula, though. All right, well, let's do it that way, because that's the way I thought of originally. So here we go. So for the red car, x is equal to x0 is 0. So we're using the second equation here. Vx0 is 33.3 meters per second. We don't know time. And we have 1/2, oops, okay, 1/2 a, which is 0, times t squared. Okay, so that's for the speeder. And then for the cop car, we have x is equal to 0 meters plus 0 meters per second times time plus 1/2. We had 2.78 meters per second squared times time squared. All right, so first let's simplify these problems. That's 0. This whole thing goes to 0. So we have x is equal to 33.3 meters per second times t. Okay, simplify the blue, that's 0, that's 0. So what we're left with is x is equal to 1/2 times, well, let's just simplify that too. So 1/2 times 2.78 is 1.39. So we have 1.39 meters per second squared times time squared. All right. So now these, again, we talked about this, that these x's are the same. So what happens if we just make those equal to each other? So what we're left with is 33.3 meters per second times t is equal to 1.39 meters per second squared times time squared. All right. Now, okay, well, they made it nice for us that we don't actually have to do the quadratic formula. Okay, so we're going to divide both sides by t so that that reduces out. That squared reduces with that t, and so what we're left with is 33.3 meters per second is equal to 1.39 meters per second squared times t. So now I'm going to divide both sides by the 1.39 meters per second squared. Now you see the meters per second cancel out the meters per second. We have per second, which is just seconds. So we're left with t is equal to 33.3 divided by 1.39, and we get 23.95 seconds. Let's just round up to 24. Okay, so it takes 24 seconds for the cop car to reach the same position as the speeder. So let me just kind of review what I did here. again. So I figured out the equations for them separately, and I knew that solving for x, right? So solving for x for both equation, we know that those x's are equal to each other, so I can just set these two equations equal to each other. And that's what I did here, set those equations equal to each other, solved using some algebra, and they left me with t is equal to 24 seconds. So that allows me to know that that's how long it took. And then how fast will the police officer be traveling at this time? So now we just need to know Vx final after 24 seconds. So I'm just going to use that first equation for the cop car, and I'll have my answer. So we know the initial position was 0. We don't know the final position. We know the initial velocity was 0 meters per second. We don't know the final velocity. That's what we're looking for. How fast is the cop traveling? We know the acceleration was 2.78 meters per second squared. And we know the time is 24 seconds. All right, we're just going to plug into that top equation, which is Vx is equal to Vx0 plus Axt. And we'll solve for Vx, and we'll get our answer. So Vx is equal to 0 meters per second plus 2.78 meters per second squared times 24 seconds, and we have a velocity of 4 times 2.78, 66.72 meters per second, which is extremely fast, because what the car was moving at 33 meters per second, so it's going to be moving twice as fast by the time it reaches it. All right, so if you have any questions about those problems, please email me, let me know, and I can try to help you. And then you should be finished with this today or tomorrow. And then take pictures of it, turn it in, or wait till you have a device to do that and turn it in once you have a device.